This is day 6 of Advent of Code 2024 Done and Go, and this challenge is called Guard Gallivant. Historians using their fancy device again, this time to whisk you all away to the North Pole prototype suit manufacturing lab in the year 1518. It turns out that having direct access to history is very convenient for a group of historians. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. You start by making a map, the puzzle input, of the situation. So for example, this map shows the current position of the guard with the caret symbol to indicate the guard is currently facing up from the perspective of the map. Any obstructions, crates, desks, alchemical reactors, etc. shown as a hash. Lab guards in 1518 follow a very strict patrol protocol which involves repeatedly following these instructions. If there is something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. So following the above patrol, the guard moves up several times until she reaches an obstacle, in this case a pile of failed suit prototypes. Because there is now an obstacle in front of the guard, she turns to the right, continuing straight in a new direction, reaching another obstacle, a spool of several very long polymers. She turns right again and continues downward. This process continues for a while, but the guard eventually leaves the mapped area after walking past a tank of universal solvent. By predicting the guard's route, you can determine which specific positions in the lab will be in the patrol path, including the guard's starting position. The positions visited by the guard before leaving the area are marked with an X. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? Okay, well, let's get started. Okay, so we'll start off with making a grid. I'll grab code from day 4 where we did that. So we've got a grid, everything in there. So we now need to create directions. This will be a list of an array of 2 items, int, and we will start off with to go up, that is -1, 0. To go right, that'll be 0, 1. To go down will be 1, 0. To go left will be -1, 0. So let's look at our input first to figure out which is first. Is it caret? Okay, it starts with caret, that makes it easier. So let's starting pos equal to, this will be list of ints, and we'll start off with empty, and we'll do for row in range grid, for col in range row, if grid row col equals caret, then start pos is equal to, well, actually we'll do 0 is equal to row, then 1 is equal to col. Oh, my bad, I should be doing row here like this, because we want the indexes. There we go. Okay, we need to change that. It's not liking having 2 underscores, so we'll do this. Okay, why is it not liking that? Range over row variable. Okay, well, I did the wrong thing there again. Okay, let's say grid row. And would this work now? There we go. So if it equals that, we do that. Break pos found equals false. Make that equal true. If break, then if this actually we don't need the first one because we're already breaking from here. Okay, so we found the position, so we've got where in the grid we're starting. We now got our direction. Actually, instead of doing this, we'll do guard row equals -1, guard column equals -1. I just think that's a bit easier to look at. And we can do if bread equals 0, so we don't need that one anymore, don't need the position. Okay, we've got that. We've also got direction. We need to keep track of the current direction. Oh, actually, what we could do, because I've got it set up as a list, we access the direction by using the index. So guard direction equals 0. So we do that, and then when we grab a direction, we go direction 0. Now we've got this direction, and then when we do 90 degree turn to the right, we +1, and now we're facing the right. 90 degree down, 90 degree left. So we'll be doing guard direction +1 modulus 4. Sweet, that worked out well. Okay, so what we now need to do, we now need to keep looping. So we'll do 4. We'll keep looping while these are within the bounds of the grid. So for guard row is greater than 0, and guard row is less than length of grid, and guard column is greater than 0, and guard column is less than the length of the first row in the grid. So we'll keep iterating until we are now outside. Although I should check, does it count I'll figure it out. I'm just wondering if it counts stepping outside of the grid, but we'll see when we test it. So do this. So we'll do current direction is equal to direction, we'll name that directions, and guard direction. Actually, we can't do it like that, can we? What we can do is, let's see, guard row plus equals current direction 0, and then guard col current direction 1. Then we do if this is if less than 0 or greater equal to length, or guard column is less than 0 or guard column is greater equal to length, we break, and that's when we print out the output. Also, the goal is at 41 distinct positions. Okay, so if it go over the same position, then that would count, that wouldn't increment it, so you do actually have to keep track of the locations. So that would mean you'd need to create a map. So we do this, and what we can do is say visited locations is equal to make map. And this will be, we'll use the current positions. This needs to be like that, and then we'll just store a boolean. So what we'll do is visited locations, and we will create a new int array like that, and it will be guard row guard column equals true. Oh yeah, we can also get rid of this condition now. So we've got our exit condition down here, so we can just keep this as just 4. So keep iterating. The current location we're on, make that true. We're now grabbing the next direction we're going, and we increment that. We then check to see if we're now outside of the bounds of the map, and if so, we then exit. What we now need to do is if grid guard row, what we need to do, we'll change this to next guard row, next guard column. This will be equals guard row plus this equals guard col plus that. We then do this check. We then do if, back to here, if next guard row, next guard column equals hash, we then do guard direction equals guard direction plus 1 modulus, modulus 4. Then we do this again right here. We will then do this. Oops, forgot colons here, that's why it's failing. And then we would also need to put this into here, I think. Okay, let's actually go back and look at this. Okay, yeah, I think that is correct. And I'm not sure what else that needs to be done. We'll just do output equals length of visited locations. Okay, let's run this and see what we are getting. Actually, although we'll let it run, but we will grab this one first and then put it into there. So currently it's, okay, we've got the file here, and it returned 1, which is obviously not correct. So I'll put that into here, and we will run it. Okay, it's giving 1. Okay, so what exactly are the values in here? So print next guard and next. These should be switched around, although it doesn't matter too much, but we'll run it anyway. So why is it breaking from here? Okay, now what are the values of the original guard row guard column? So that shouldn't be negative like straight away. Okay, so that's int, that's the rune. Okay, what I need to do is add that to here. Okay, so there's never a time where it's equal to that. So what we now need to do is figure out what exactly is happening here. Is this just not running? Okay, well now what's in grid row? Okay, so it's just empty. Okay, we'll go a step up. What's in lines? Okay, so what is up with this input? What is in lines 0? Okay, so that is working correctly. Okay, so I haven't actually put the lines in yet. Okay, that's what's happening. So we do that. Now we need to do for line in range lines. Actually, we can do I. Grid I is equal to rune lines. So now that should work. Okay, I've done this wrong. That should be there. Okay, let's get rid of all these prints. Now let's run it. Okay, seems like I might have an infinite loop here, so it's not ever stopping. And that's because I didn't do guard row equals next guard row, and then next guard column is guard column. That's why that wasn't working, so now let's run it. And I've got 16 which is not correct. Okay, maybe we need to, let's print it like this instead. And then we can also go down here and print so we can see the movement it's doing. Okay, we need to change it so it's like this, I think. Does that work? So let's see. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. So it is 4, but somehow it got 5. And that did seem like it worked. So it went up, up. Oh wait, no, yeah, this is, yeah, wait. 0, 1, 2, 3, 4, 5, 6. That should be up here. It should be, start off with a 6. Let's move this print to, okay, yeah, that would be why. Move that print to here and do that. Okay, there we go. So it goes up to here and then goes to the right. So this is 0, 1, 2, 3. Okay, it will do 6, 1, 2, 3, 4. So it goes 5, 4, 3, 2, 1. And does 5, 6, 7, 8. Then goes down 2, 3, 4, 5, 6. But then for some reason goes up again. Did I do... Okay, I did the wrong thing. Okay, I did it all wrong. So, need to move this one. No, that's right, that's right. Okay, this is meant to be 0, and this is -1. So now rerun it. There we go, now we're getting 41. So let's just get rid of these prints so we don't have them anymore. Run it. We will switch to our actual input. 5162. Okay, cool, that is part 1 completed. Now on to part 2. While the historians begin working around the guard's patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard posts on the walls of the closet. Returning after what seems like only a few seconds to the historians, they explain that the guard's patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible locations for such an obstruction. The new obstruction can't be placed at the guard's starting position. The guard is there right now and would notice. In the above example, there are only 6 positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 positions use the arrow to mark the new obstruction, a pipe to show a position where the guard moves up down, and a dash to show a position where the guard moves left to right, and plus to show a position where the guard moves both up, down, and left to right. Option 1. Put a printing press next to the guard's starting position. Option 2. Put a stack of failed suit prototypes in the bottom right quadrant of the mapped area. Option 3. Put a crate of chimney squeeze prototype fabric next to the standing desk in the bottom right. Option 4. Put an alchemical retroencabulator near the bottom left corner. Option 5, put alchemical retroencabulator a bit to the right instead. Option 6, put a tank of sovereign glue right next to the tank of universal solvent. Doesn't really matter what you choose to use as an obstacle, so long as you and the historians can put it into position without the guard noticing. The important thing is having enough options that you can find one that minimizes time paradoxes, and in this example, there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? Okay, so I think I've got an idea for this. So, start off similar as before. Actually, I just want to check again. Does it mention that the guard has to walk into it? I don't think it does. So what you can do, we'll start off with the grid. What we need is, we need a list of obstructions. So we go through the obstructions. We have the x and y coordinate of an obstruction. We see which obstructions are also having the same x, which obstructions also have the same y. And if there's, with those, you can, say you have this point here, you then find one, okay, this one is here, and this one's here. So there are obstacles on the same x and y. You then go, okay, go put one here. So that's how I think it would be done. But I didn't see it mention, I don't think you have to worry about the guard actually walking into it. So we'll do, okay, how do we want to do this? So we'll grab similar code to finding the location. We'll get rid of this. We'll check to see if it's equals hash now, and we'll create, we'll just do a list. So obstructions is equal to, what will this be? It's a list of 2 ints, like so, and this will be obstructions equals append obstructions into row column, and we build that up. Oh, I forgot to put int in there. So we do that, we've built it up. I want to print it out just so I can see if it's correct. Obstructions. We'll return it back to this test input. Obstructions looks correct, I think. Let's see, so there's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That works? No, it doesn't work because it's not. They're not going to be directly in line with each other. They need to be offset. Okay, let's go back to this. Okay, so we'll need this directions back again. Okay, that makes it a bit tricky. So I've been thinking about it for a bit, and I think I was wrong in that I think we need basically all this code again. So what we'll do, we are going to run through the guard going through the entire map. And what we could do is, for every, what would it be? I think we would have to like test it, so we're running through as normal, but each step of the way put an obstacle in front and see whereabouts they go. Then if they don't get stuck, then put an obstacle. If they don't get stuck, put an obstacle. If they don't get stuck, put an obstacle. Okay, they're moving and they're in the same position. I think that's how we would do it. Okay, so let's copy this code and we will put that all here. So we've got it all. The original code is part 1. Code's now in part 2. I think we need to kind of just like iterate over the grid. We just place a new obstruction. We then run this and see if it gets trapped. Would that be it? Yeah, I think maybe so. So let's copy this. Well, we don't need all of it. We just need. Actually, I don't know why I said it like that. I should have done just a normal for loop. Row is less than length grid row plus plus. Then we do the same thing here, but col row is less than the length of grid col and col plus plus. So we'd have that, and everything in here. Tab over twice. Now we need to close those 2 for loops. And what we need to do here is if grid row col does not equal a dot, then we continue. Okay, so we've got that. What we then need to do is set up grid row col equals hash, and then we'll at the very bottom here need to undo that, so equals dot. What we then need to do, create a list of visited locations, but we also need to include the direction they are going, so we know if they're going in the same location and in the same direction, that means a loop has occurred. So visited locations, actually we can grab that, place that here, change this to 3, and in this one it would be guard direction. I need to change it to 3 as well. And as we're using those values in here, we need to do, say, current row equals guard row, guard col, guard direction, current col, current direction. Need to add the columns here, and we will add a variable loop detected equals to false. So then we're doing this as normal. So I've got this. We don't want this straight away. We'll do guard state is equal to this, and we'll do if visited locations guard. Keep forgetting the colon. So then guard state. There'll be a loop detected equals true. Break. If that's not the case, then we put guard state into here. We then do this as normal, and I think everything else stays as it is. Oh yeah, I need to change it so it's current like this, and also down here current col should be current row, current col. Same thing here, current col, current row. I think that is all of them removed. So then loop detected, if we do if loop detected output plus plus. I think that's everything now. So let's try it on this test input and see if it works. What's going on here? Oh, I accidentally put col there. Row. Now rerun it. And I got 4. Wait, what's going on with the outputs? Did I accidentally change something in here? So even day 1's not working correctly. Part 1. Okay, so it turned out I've got this from the original part, but that doesn't really matter. But what does matter is why... Okay, what is the actual answer for that? So that one should be giving 6. Okay, I guess what we can do... Where's loop detected format dot f print line state guard state, and whereabouts is it happening? So 6 4 and 4, that's going left. So 0, 1, 2, 3, 4. Okay, I've got no idea if that's right. Would have been more useful if they actually gave the numbers on here. Oh, actually no, that is correct. So that is 6, 4, trying to go left. So now 7, 6. So what is that? That's this. So that's not the one we found. So we got that one. Didn't get that one. Don't think we got that one. Wait, we got a duplicate. Is it possible I'm not clearing it? That looks right. Now what's 8, 3? So 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3. So is there one which is like this? It's close, but... Okay, so just looking at this, it does seems like... So I was saying, could this be a mistake? But no, it's not. It's like just this. It's possible to be like at the same spot multiple times, I think. So this one puts you back to your starting location. But apparently there are 6. Maybe we should print the grid when loop detected. Okay, that's not what I was planning, but I guess that makes sense. Oh, I see the issue. Wait, okay, there's multiple issues. Firstly, current direction, guard call. That's not right. Guard direction. Now for this one, guard direction should be current guard direction, like this. Okay, wait a minute. Okay, I've been using... okay, I used different variable names. Okay, we'll change this to current guard direction. This will be current guard direction. Current guard direction, and then this is guard direction. So we'll do current guard like this and this. There we go. So hopefully that's the only issue I had. There we go, we're now getting 6. So now let's put our actual input back in. Taking a long time to run because it's very inefficient. Oh, but it's completed. 1920. So let's put that in and see if it's worked. Doesn't seem right. Okay. That's not what I was wanting to see, but I guess there's more we need to find which is wrong. Okay, I want to change this just so we don't really need to create a new variable for this. We could just do this, and I prefer to have it current direction. So do that, get rid of this, and now we're just directly putting the value like that. Then we'll need to do the same thing down here. Don't rename you, remove this, and we will do this again. So that's just one simple thing to make it clearer. Another thing can change because we've got all these checks. So when we need to rotate, currently we're rotating and moving, could change it so we just rotate and then do another iteration, and then on that iteration, that's when we move forward with this new direction. So I feel like this is a bit messy. So we'll do this, remove this part. If current row, current column is this, all we do is do this. All we do is change the direction, but then inside of here we do if we're not, okay, so this one is if the current location is out of bounds, then we do that. If we're inside the bounds, if we're on a, is that right though? No, I've done the wrong thing. Let's undo a bunch of it. Yeah, we need to undo all that. So it's halfway right. So we keep this and we do this, but else in here. So we do go to the next one. If it's out of bounds, we break. If it's not out of bounds, we keep our current, so we're not changing it, but we just change our direction. Let's go back to test and see if that still works. Still getting 6. Let's try go back to this one and see if we get new output. Okay, so I've got, I can't remember if that was the previous one we tried, but let's try it. Ah, well, it's now working. I'm not exactly sure what I fixed here, but it's working. Well, that is day 6 of Advent of Code 2024 completed in Go. So if you like this video, make sure to like and subscribe.